from those shallow waters and the wind, the action of the wind on those waters leading to ripple deposits. And we found here that the minerals actually indicated very acidic waters, pH less than 4. So we think we're looking at shallow, salty, seasonal acid lakes. On the other side of the planet, when the Curiosity rover landed at Gale Crater and we began our explorations at this location, instead here we found very thick sequences of mudstone, like you might find in the bottom of a deep ocean or a deep lake. And here, the evidence is for neutral waters, waters that you might want to jump in that lake and take a swim. Sometimes fresh, and then occasionally, as we've gone higher up the mountain, and more recently in Mars time, sometimes salty. What's interesting though is this is the first time that we've had a detailed package on board to characterize not only the minerals, not only the chemistry, but the organic matter. And indeed, Curiosity, the mass spectrometer on board the rover, has discovered organic matter within these sediments. Is it life? Probably not, but as we've gone further and further in this traverse, we see more and more complex organics, indicating that there was processing of organics on the surface and that we need to keep looking, because these are very intriguing results and the building blocks of life are there. So multiple types of Earth-like habitats varying around the surface of Mars until about 3 billion years ago. And so we're on a path right now to solve these questions on Mars. What is it that created the early climate system? What is it that caused it to change? By our orbiters, by landing rovers, we're beginning to put numbers with volumes of ice, volumes of atmosphere, isotopic ratios to be able to trace the processes through time. If any of you want further reading, these are some of the latest papers where we think that actually episodic release of greenhouse gases may have warmed Mars, but then the actual creation of these hydrated minerals that are the evidence of water dried out Mars through time by pulling that water into the crust, even as some of it was lost to space. So we're on this path to answer these questions about what is it that makes a habitable world and what is it that allows it to sustain or not habitats for life. So in my last few minutes, I'll just say a little bit about the future of exploration. The future of exploration is now. We are still on the surface, we are still exploring. This is a delta deposit from Jezero Crater, Mars, where the yellow dot is where our rover landed about 500 days ago on the surface, and we've been driving up actually onto this delta deposit right now. The Perseverance rover is the first to do a number of things. It is the first to have a little helicopter on Mars, Ingenuity, which has been a tremendous development. The Ingenuity helicopter has allowed us to scout ahead of the rover to figure out where we want to go. We are flying a helicopter on Mars, right? This is pretty cool. And it has allowed us to pick out those locations that are most important to go to with the rover, where Perseverance is collecting cores from the surface and collecting them and storing them on board the rover. Why? Because we want these rock samples from these most habitable environments that we're finding on Mars. We want to bring them back to Earth, much like we did with the Apollo samples, much like we did with the Russian sample return missions. We want to take these rocks that preserve evidence for water and rock interaction, these rusty spots, these salts. They are the places to search with the best techniques in our laboratory to look for life. So we're bringing these samples back, we're collecting them. You'll hear more about this from Scott Hubbard. But the rover is in the middle of a marathon traverse from Jezero Crater out to even more ancient, that Jezero Crater that once held a lake, out to even more ancient rocks from the past, tracing a billion-year profile of Mars history through these samples. So what's to come are the missions of the sample return campaign. But there is more to discover, there's more to do. We have not been to the poles, we have not measured heat flow, we have not explored the canyons of beautiful Valles Marineris behind, so there is much more to do. One day perhaps there will be humans, but in the meantime, and I hope some of you get to play a part of this over the next years, in the meantime, these rovers are us. They're our proxy, they are our boots on the ground on the surface, they're our eyes on the surface, and they are us exploring our nearby world. So thank you very much.
Thank you so much, Dr.